now to continue with our lightning talk in this track. We have only one lightning talk, which will be presented by Florencia Nowogrodzki. I hope I pronounce well your surname. Florencia is from Argentina, and she will present her talk about redefining bronchopulmonary dysplasia by machine learning discovery of lung disease trajectories in premature infants. So thank you so much, Florencia, for being here, and thank you for being now at this time for doing your presentation. So when you want, you can start.
As you said, my name is Florencia. I'm a physician from Argentina, and I'm going to present the work we do here with my team, which is called Redefining Bronchopulmonary Dysplasia by Machine Learning Discovery of Lung Disease Trajectories in Premature Infants. So, okay, now I wish it's sorry now.
Yes, perfect.
So, 1 in every 10 children are born prematurely. Bronchopulmonary dysplasia, BPD now on, is one of the most common causes of mortality and morbidity regarding this group of people. This illness is associated with long-term outcomes such as pulmonary, neurological, and outcomes which even include death. The many possible endotypes, which are different underlying mechanisms of physiopathology, are still unknown for BPD. Therefore, we believe that BPD could be an umbrella term that encompasses different diseases of pulmonary problems. The current diagnosis of BPD is a retrospective assessment that takes part in the 36 weeks of gestational age, in which we retrospectively analyze the needs of oxygen from the baby. So if at this particular time in the baby's life, he needs at least 20 days of treatment with oxygen of more than 21%, then it is diagnosed as BPD. Afterwards, we need to define the severity. So if at this particular moment they are breathing room air, they are defined as mild BPD. On the other hand, if the needs of oxygen are between 21 and 30%, they are considered moderate BPD. Finally, if the needs are beyond 30% of the baby require positive pressure, then it is defined as severe BPD. Regarding this definition, we found some weak points which are presented in the image on my right side, which shows 3 different cases. In the first one, we represent some babies who has high requirements of oxygen during their first days of life, but after that it starts to diminish on time. So at time of assessment at 36 weeks of gestational age, they are diagnosed with severe BPD. But many of them may not have long-term outcomes. Secondly, in the second case, we propose some babies who die before time of assessment. So, do they die because of BPD or not? Finally, in the third case, we represent some babies who has low requirements of oxygen during their first days of weeks of life, but after that, they start to get worse and need more fraction of inspired oxygen. So they are diagnosed with no BPD, but after all, they may have long-term outcomes. So we, here in Argentina, we have prospectively followed 378 premise with their parents in 5 different hospitals of the city of Buenos Aires. We have collected demographic, epidemiological, and perinatal data, as well as we have followed up these babies during their time in an ICU in a daily basis. So we call it the DBPD program, the Discovery BPD program. The aim of our work is to discover a novel methodology tool for assessment in an earlier diagnosis and a better identify of children at high risk. After exploring different algorithms such as TRAG, KML shape, we identified anchor chimedoids, which is an adaptation of longitudinal Kimin's clustering technique for analyzing trajectories based on long-term trends. So the objective of chimedoids is to create groups within the minimal possible distance between individual trend and group trends. We decided to use the first days of life independently of the gestational age, and we analyzed the maximum fraction of inspired oxygen of every one of our babies. So our algorithm shows that the best number of groups to clusterize our cohort is within 3 different groups. The first one, which is cluster 1, is the stable one, which encompasses children who has low requirement of oxygen during this time. Whereas the second cluster is composed of babies who has high requirements of oxygen during their first days of life, but after that they start to improve. Finally, our third cluster is generally composed of baby who has low requirements of oxygen during their first days of life, but after that it starts to deteriorate and the requirements are higher and higher. So we grade them in order of severity from cluster 1 to cluster 3. In order to validate our analysis, we decided to apply the algorithm to an independent cohort that is called Prematurity and Respiratory Outcome Programs, which was developed in the United States, which included more than 8,800 children. And in this table, we can show both cohorts, the DBPD cohort and PROB cohort. There is a third one, which is called DBPDP. We create this cohort based on our cohort, but we selected only the child who has the same gestational age as PROB child. So, first of all, we decided to compare memberships. Each of our clusters is populated with babies with all of BPD diagnosed. Strikingly, our third cluster is again encompassing children with all of range from no BPD to severe BPD. But the vast majority of our third cluster is or were diagnosed with severe BPD. To assess the power of our method, we decided to compare clusters with outcomes such as retinopathy of prematurity, intraventricular hemorrhage, and final outcome. So regarding retinopathy of prematurity, we can observe 2 different images. In one, we describe ROP within the current diagnosis, and on the other hand, we can observe clusterization with ROP. So in this slide, we have a greater percent of severe ROP disease in our third cluster than we have in severe BPD group. Even more, we have greater percent of severe disease in the moderate group than in severe group. Something similar happens regarding intraventricular hemorrhage, in which, regarding clusterization, there is a great scale in which we have lower percent of severe disease in our third cluster than in our third cluster, which have the highest percent of severe disease. In comparison with current diagnosis in which this is not actually happening. So we have low percent of babies with severe disease in moderate group than in no BPD or mild group. Finally, but the most important outcome for us is final outcome, which is a dichotomic variable that includes both alive or deaf children. Painted by orange, we can observe deaf children. And regarding clusterization, there are mostly all of deaf children in our third cluster. Whereas regarding diagnosis, this is again not happening, and we have a greater amount or a greater number of deaf children in no BPD than in moderate group. To conclude, we believe that our method has a high value of predicting long-term outcomes, and our strength relies on a fewer need of days until assessment, as well as we not only use or analyze oxygen requirement, but also the quantity of these requirements. I would like to thank all the team. We are a lot of people working in different parts of the world, and it couldn't be possible without all of them. And of course, I would like to thank you for this time, for listening to me. I hope you enjoy it. And of course, if someone would like to ask me something or to comment something, it would be really nice for me. Thank you very much for your time.
Thank you, Florencia, for your presentation. It was very clear. I enjoyed it. I hope most of our attendees enjoyed too. It was a really interesting work. I suppose that there's a lot of work behind of your presentation.
Yes.
And I will wait.
I was late when I entered to participate in this work. I mean, there had been a lot of people working to make it possible. So I'm just a little piece of this whole or huge work that other people as well as me have done.
Oh, it's a really nice work. And I will check if we have some questions. You have some congratulations in the chat, and questions for this minute. I want to ask you maybe, do you try some another algorithm, machine learning algorithm, before using AK mediums? What was the experience? If you want to tell us.
Yeah, we did. We explored TRAG, KML, but then when we compare that clusterization with outcomes, it has no sense until we discover this one. But we also have some problems because our gestational ages are widely different between one and another kid. So here we find an algorithm that defines clusterization regarding or independently of their gestational age. So with some other algorithm, we have problem in this particular assignment.
Okay. Another question I will do if
Okay.
we have time, so we can take advantage of it. So we have, or maybe are you working on integrating more data or different data, different type of the data that you have used? Have you tried with the image or something like that? Or it is impossible? Maybe I don't know because I don't know anything about the disease. But
Okay. What do you mean by images?
yes, data from images, maybe from the lung. I don't know if it could be helpful or not.
No, not in that way. We are trying to use, for example, epidemiological data as well. I mean, from risk factor to outcomes, and analyze all of that information. That it's really important to understand that we studied population that it's really hard to study because they are really, really small. They have a really severe disease, and it's difficult to like use invasive techniques or tools either to diagnose or to treat them. So we are in that kind of questions where like we have information but not too much information, and with the time we started to make possible to younger newborns to be alive. I mean, this wasn't happening 20 years ago because these babies couldn't have lived because we cannot save them in a way, and now we can. So it's really a novel disease which we don't understand deeply.
Okay, it's perfect. And I think that works such as your work are contributing to improve our understanding of this kind of diseases. So congratulations.
It's what we wish to do.
Yes, I think that it was a really nice work. So thank you so much for being here.
Thank you very much to you for letting me be here and enjoy presenting this work that I really love.